Question 7. Metal X has half the resistivity of metal Y and length 3 times that of Y. If both X and Y have the same surface area, the ratio of their resistance Rx to Ry is. Now, I don't really like this word surface area. It should be cross-sectional area, because when we're looking at this formula, we're dealing with that area there, the cross-sectional area there of the wire. So which formula are we going to use? Well, obviously we're going to use this formula over here. So if we have Rx, we have that over Ry. Rx says that metal X has half the resistivity of metal Y. So if this is 2, this would be 2 rho of X, and that would be rho of X, the resistivity. And then the length, it has a length 3 times. So if this is L, if this one is L for Y, this would be 3L for X, and they both have the same area. So when you divide both of these by the area, they're both the same. Now, I think we can see that we're going to get px, and px is going to cancel out there, and we're going to get our L will cancel, and our area, that will cancel with that. So we're going to get a value of 3 over 2. So I would say that A would be the correct one there, that it is 3:2. Question 8. 3 identical resistors of 3 ohms are connected in parallel in a circuit. The effective resistance would be. So we've had this question basically before. Because they're connected in parallel and it's 3 ohms, we're going to use the formula 1 over RT is equal to 1 over 3 plus 1 over 3 plus 1 over 3. And a third plus a third plus a third is 1. So RT, when we inverse 1, is obviously still 1. So it would be 1 ohm. So it would be A. Moving on here to question 9. Question 9 here. It says, if 18 joules of work must be done to move 2 coulombs of charge from point A to point B in an electric field, the potential difference between these points A and B is. Now the formula that we're going to use is V is equal to W over Q. That your potential difference is the work per unit charge. So this is pretty straightforward. It's going to be 18 joules divided by 2 coulombs, so it's going to be 9 volts would be the correct answer. Question 10. The fundamental SI unit, the ampere, is defined in terms of. Now, we will discuss this in detail, but it's determined in terms of the force acting between 2 current carrying wires. That's how A is actually defined. Although we think of the ampere is 1 coulomb per second, the way that we actually define it is the force between 2 current carrying conductors, and we'll discuss that in more detail later.